We have another exciting show here today and a great guest. Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Merek Chertkow. He is the founder and CEO of the Radiation Team. Welcome to the show, Merek.
Thank you very much. Thanks for having me.
Absolutely. Maybe we can start by having you just give a little bit of background on yourself and the Radiation Team.
Sure. I could talk for an hour on that, so I'll try to give you the brief version. I graduated with my PhD in about 2012, and that's when Facebook was relatively new, right? And I'm like, hey, I'm graduating with my degree, and an old friend reached out to me and said, "What are you doing?" And this person I had worked with as an intern in undergrad. So interns, go get intern experience. Networking matters, and experience matters. So this person happened to be working at SpaceX at the time, and he's like, "You were a great intern to work with. You're a smart young kid. Like, come interview at SpaceX." So I was like, "What is SpaceX?" This is 2012. And so I had a decision between going to postdoc and going to work for this company called SpaceX. And I always wanted to work in space. I love space. Space is my religion. And so maybe that'll be a theme here. So I took the leap and I decided to go work for SpaceX as an EMI EMC engineer. I got my degree, my PhD in computational astrophysics. So I knew space and I knew environments and I knew where all these particles come from in supernova explosions, which is why I got hired on the EMI EMC team. Try to give you the brief version. Sorry. So,
No, this is good. This is
yeah.
really interesting. Keep going.
Okay. So we started working on EMI team. I learned how to be an EMI engineer because I was a PhD physicist with limited engineering experience, right? Picked that up, but the team at the time worked on survivability, so they were responsible for radiation nominally, but SpaceX wasn't doing anything radiation. And back in those days, that's when we were doing the EELV program and also starting to develop Dragon to go touch the space station and ultimately Crew Dragon. So aerospace, Air Force, and NASA started asking some hard questions about radiation, which they knew very well, right? Our field isn't new. It's actually really old because as soon as we started putting computers in space, we started seeing that weird things started happening to those computers. Um, so SpaceX was doing nothing with radiation really. There was one little test that NASA made them do, but they didn't know what to do with that data. So we started having to work on some of these problems. And we were like, oh, well, what is this and what is that? And I had never heard of radiation effects. And the point is that me and a couple of other engineers, we just started doing research and figuring out what these problems were so that we could answer questions and start addressing problems and start asking, well, let's go test and let's do some analysis. And how do you do the analysis? So I mean this in a nice way because this is a good thing. But the fastest way to get fired at SpaceX is to tell Elon, well, this is what the industry is doing, so we should probably go do it, right? Like that's the opposite of what SpaceX is forget about what the industry is doing and go do the right thing. And so we developed radiation with first principle type approach engineering, saying what do we actually need to go do, and more importantly, if we're going to tell an engineer that they need to slow down or they need to change something or they need to fix something, you better be right. Otherwise, you're slowing Elon down. And again, like that's bad. That's bad news at SpaceX. You don't get those. You don't get second chances in that way. If you're just like, well, I think maybe we should do this because it's a hunch. Like, no, you have to prove why you got to do what you got to do. Sorry.
Wow.
So you build up a methodology that is kind of a theme here, which is what I call like necessary and sufficient engineering. What do you really need to do? What is really important? What are facts? What are results? Right? What is phenomenological evidence that there is a problem or there's not a problem? And if you don't have that evidence, then there's no problem until something's on fire, until you go do it.
Yeah.
So we spent 7 years at SpaceX proving to NASA and aerospace and Air Force what problems we had and what mitigations we were applying, and more importantly, what problems we didn't have, like why we shouldn't go do things that the industry thinks you need to go do, and arguing and justifying everything. And so that's where we started over from scratch, like a radiation methodology, and I built up a team to ultimately go produce Starlink, right?
Yeah.
Um, and so that's how I started my radiation career, and out of that, a radiation methodology. Of course, there's a lot of IP at SpaceX that stayed at SpaceX, but like just good engineering practices are something that I can carry with me throughout my career, right?
Yeah, that
Um,
sounds
and then
amazing.
yeah, yeah. And then so ultimately I decided to go to Blue Origin because I wanted to have kids and kind of a different lifestyle. And I thought, oh, Bezos is also going to go produce something amazing. So I built a Rad Team there, started over from scratch, did that for 4 years. Now I'm speeding up, sorry. And
Yeah.
ultimately, I realized that with the proliferation of commercial space, there's so many companies that all are going to have a variety of radiation issues, some small, some large. And rather than help Elon's 5 programs and Jeff's at Blue Origin's 7 programs, I'm just making those numbers up to paint a cartoon picture. There's hundreds and hundreds of companies that are going to have a variety of radiation effects issues, and there's not enough radiation engineers to support them all. Even if they all had the resources to go hire their own teams, there's going to be most of the companies aren't going to get what they need. And having built radiation teams for most of my career, I realized that I can do that independently and help as many people as possible. And that's kind of what spawned the Rat Team.
Wow, that's amazing. So that even kind of covers my first question was which was kind of what inspired you to start the Rad Team, kind of for short for the radiation
Yeah,
team,
yeah.
in 2022, and what gap did you see in the industry? So it sounds like you just really saw that there just weren't enough radiation engineers, people that understood this.
Yeah, that's right. I mean, I could have stayed at Blue, and I could have helped those programs, and that's great and awesome. But going back to what I started with is I love space. I want to see a bunch of cool people do amazing things in space. I want to see humans solve new problems and develop new things, and SpaceX and Blue Origin and other companies will definitely do that. But in this capacity, I feel like I can make the biggest impact possible. So it wasn't so much like, oh, I see a business gap, I can go make a lot of money. It was
Yeah.
more, oh, I see a technical gap, I can go help a lot of people. And being successful in business will be nice. It will be fun. Money's good. It's an awesome metric. I'm not saying that any of those things are bad, but it's not truly the reason I'm doing this. The reason I'm doing this is because I want to make as big of an impact as possible because we're at an inflection point in whether this is a space bubble and how many companies get assimilated into other companies or whatever ends up happening. We're at a really unique time in history where commercial companies are trying to do a lot of amazing things, and I want to be a part of that, and it's a ton of fun.
What an inspiring mission. That is amazing. Amazing. I love it. So let's talk about how what you're doing is actually lowering that barrier, kind of those major barriers to entry for commercial
Yeah.
space companies. How are you
Yep.
doing that?
Yep. Um, so the answer is by helping them not waste their resources. Uh, uh, I'll talk about the commercial guys in a second. So there's like 3 primary customers, right? There's government, defense, industrial base, what people call old space. I don't call it old space. It's just the kind of status quo of what existed. And then there's the medium-sized companies like SpaceX and Blue Origin and larger companies that have enough inertia and have enough influence and money to go be successful in their own ways. But then there's a lot of the startups who, phenomenally smart people, awesome ideas. Maybe the timing is just right, or maybe the timing is wrong. They're going to fail for a lot of reasons, but there's a lot of reasons they could succeed as well. And the startups, have very limited resources in both time and money. A lot of that is driven by VC funding, but a lot of it is just driven by success, right? They have to
Mhm.
commercially become viable somehow. And those companies, each one presumably has some secret sauce or some new methodology or some niche that they're trying to fill, or first to market. And they have a lot of problems to solve. And space is not cheap, as we all know, and it's not easy, as we all know. And one thing companies should never be doing is wasting resources and spending time doing things that aren't actually moving them forward, right? It is again our motto, like necessary and sufficient engineering. Go do the thing that needs to get done and stop wasting time doing anything else. And so the field of radiation effects comes with a lot of conservatism. You can imagine for strategic military reasons it shall work, right? Like the amount of money that you spend doesn't really matter, and the amount of conservatism that you inject into that to ensure that it works is very important. And
Sure.
so when you're talking about those type of military systems, you should say let's be too conservative and let's dump in more money. But as those processes and methods and engineering technology, we'll call it, translates to the commercial space, that breaks the system, it breaks the business model, it makes it not work. And so, for any commercial company that does have radiation effects problems to solve, the question is, how can you solve them in the most efficient way and in an ROI, in a way that it impacts ROI in the best way possible? So, one example is, well, I'll give you two examples. If there's a company that is doing something in LEO and they, for whatever reason, want to go to GEO, uh, uh, there's going to be some things that they're going to have to fix in radiation because those are very different radiation environments. So
Uh,
a lot of people are taking terrestrial technology and they say, okay, our startup, we're going to do some things in LEO, and then 5 years later, we're going to go do things in GEO. And so where we help is we don't say, well, let's solve your GEO problem today. It's like, no, because if you're not successful in LEO, your company's done and you're going to fail. So let's solve the LEO problems today, and let's only spend the resources to make sure you're successful to get over the next horizon, and then solve those other problems later in the future. And that is, one example. It's not the definition, but it's
sure.
a really clear example of like lowering the barrier so that you can get into space, so that you can be successful, so that you can solve the next problems, and or get the next VC funding or prove out your technology or whatever it is. And
Right,
so so
right,
so that's how we're helping. One
right.
other, sorry, quick example is, if a company wants to go do a 5 year lunar mission, we say, cool. What do you mean 5 years? Like, how about 4.9 years? And they say, well, that's okay. Well, how about 4.7? Well, that's okay. It's like, well, where really do you want me to draw the line? Because it's you can always spend more money getting an exact answer as opposed to spending less money and getting a more broad answer. And I can say, hey, I can spend $1,000 and you'll survive somewhere between 6 and 10 years, but it would take me millions of dollars to say you survive exactly 5 years and then die the next day. So how about we just solve the problem in the easiest way, kind of back of the envelope approach, and then stop wasting resources if you don't have a problem. So all of these things are lowering barriers of entry to help the commercial companies succeed. And that's what
Right.
we do. That's what we care about.
Okay, so when you look at your development, what have been some of the biggest, I guess, technical and market challenges that your team has run into just as, I guess, as you're bootstrapped, right? So you're not,
Yeah,
you don't
yeah.
have VC funding. So what have been some of those
Yeah,
challenges that you've run into?
sure. Um, so for context, we're not a business that should have VC funding, right? We don't need $10 million so that we can go develop a thing in 5 years, and if we run out of money, we're done. Like that's what a lot of space companies are trying to do, and that's how that works, and that's okay. Rather, we I think the answer to your question is the same for both technical and marketing. We have a lot of expertise to go solve a wide range of problems. So radiation effects can affect you down at the IC level. It can affect you in software. Your system architecture can be one mitigation, where you're going in space, what the environment looks like, what your requirements look like. And so when a company has a radiation problem, the solution space can be really, really broad. We might be changing the architecture and their fault tolerance. We might be changing their mission operations. We might be changing their ICs. And so, in order to solve that problem, you need the right kind of engineer. You might need an FPGA engineer, or an electrical engineer, or a software engineer, or a systems engineer, or an environments engineer, a physicist who can understand statistics. Sometimes the answer is just go test more and get better statistics. So
Sure.
the challenge that we have is a scalability problem. Not that we have, that the challenges we had to solve when we were first starting. We got really fortunate that a lot of our customers all asked for the same thing. So as a new company, the processes, the technologies, the capabilities, the resources we were dedicating to were all of one class, and it was like SEE testing and a little bit of analysis. And then as more customers came in and more clients came in, they wanted more analyses, and so we had to build out our analysis tools. And then later on, as more and more clients came in, like they started wanting another kind of testing, which is called TID testing and dose testing. And so we had to build up that test infrastructure and get access to those resources. So we were very fortunate. You asked what were the challenges, but I think it was navigating hiring the right type of engineers to work on a wide range of problems, because you can't hire one engineer to do everything, right? There are mechanical engineers, there are software engineers, there are electrical engineers. These are degrees, and
Right.
and building out a team that could handle the requests of the customers in a way where we're not being pulled in two different directions was the challenge to solve. And I think that we've done a really good job of scaling of getting to a place where we can fundamentally do anything now. And now it's a scalability problem. And how do I hire my second or third or fourth electrical engineer or FPGA engineer, whatever the market demand needs from our clients.
Oh, wow. And are you recruiting right now, just while we're
Yep,
on that topic?
yep, we are. So we've actually been hiring. We just hired 3 people, I think, in the last month. And if you go to our website, we have our job recs open, and of course we post them on LinkedIn. And it is a spread of people. It's radiation engineering, basically anyone who has experience in that. It's electrical engineers and software engineers, and we just hired a technical project manager because per that topic, where every client needs something different, and so we need to make
Yeah.
sure that we never commit to something that we can't deliver on. That's the name of the game, of course.
Amazing. Okay. Kind of looking back, and I think you've already talked a little bit about this, but just looking at your background, your experience at SpaceX and Blue Origin, how has that influenced your direction as
Hmm.
an entrepreneur?
Yeah. So it's always influenced my direction as a technical leader and manager at these companies, right? It's I think the two main topics are probably like extreme ownership, which I'm sure lots of people have heard about at SpaceX. It's I think it builds a good culture. And what I mean by extreme ownership is when we hire people who are capable of really owning a project or a product or a solution to a problem end to end, it means they're responsible and they get the resource and they get to make the decisions on how best to get there. Of course,
Hmm.
ideas, goals, budgets sometimes are constraints,
Sure.
um, but I think that providing your engineers with extreme ownership means everybody plays a critical role, and it gives really good job satisfaction as well, right? It means people are actually doing something. It ensures that the algorithm doesn't allow them to be micromanaged because they own that. It means they're also responsible if it doesn't go well, but that's the name of the game. And the other one is necessary and sufficient engineering. And if people truly own the problems or the things that they need to solve or the products that they need to develop, and you ensure that everyone at the company is only doing what is necessary and not wasting our resources and certainly not wasting client resources, then you get the best results out of that. And I think that at SpaceX, I learned both of those extremely well because this, what do they say? Necessity is the mother of invention, right? And so when you don't have a whole lot of money, you don't have a whole lot of employees, you invent and you automate, and people have to own stuff because you can't micromanage. You have to rely upon people to truly, you know, understand what it is they're supposed to do and be responsible for it. And they only do things that are critically important. And by taking both of those lessons and applying them to a company as an entrepreneur, I think it makes a successful business that's hopefully not wasteful, where people like working and we work on critical projects. And so I think that's what's hopefully I've been able to pull off here.
That's great. When you look at your team and your core services, can you kind of break those down and talk a little bit about how you're supporting a typical space mission?
Sure. Um, without trying to give you a radiation 101, it's two primary categories. There's testing and there's analysis. And analysis is super general, and testing takes many forms. There's multiple forms of testing. But that's what everybody needs. They either need to understand the system that they've built and how sensitive it is to the radiation environment, and that's the analysis side. Is once you've tested something, temperature is an easy analogy. Stuff is made of things, and depending on how high of a temperature they can survive to and keep working to, they break or they don't break. And that's a super cartoon picture without trying to give you Rad 101. So we go test things to understand how they break or how they change, and how they're going to be affected by the analysis side, which is the environment, in consideration of how the system is used. If something is off when it's in flight, then it may or may not be more or less sensitive. And so we got to do the analysis side. And so those are the services we provide to clients. But I think what's more important is I like to say, for example, we are not a test house. A test house makes money by testing things. And so they want customers to test everything because that's how they survive, right? And so the what do they say? Like, if you have a hammer, you're trying to, all you see is nails, right? Or convincing everyone that they're a nail for our hammer. What we do here at the Rad Team is we like to couch ourselves as more as like strategy advisors who are excellent engineers who can execute. So we're not trying to sell a particular product or a particular service to clients. Rather, we look at what a client is doing and we say, what do they need? What is their optimum solution? And you can either look at it in a land of infinite resources. What should you go do just from an engineering perspective? But of course, companies have constraints. Some companies might not have enough schedule, or they might not have enough money, or they might not have the engineering resources. So a best solution for a client might be go fix this in software. And then they say, well, I don't have any software engineers. And it's like, well, okay, then go fix it in hardware. And they're like, I have lots of hardware engineers. And so we can do anything with respect to radiation effects. And I'll comment on why that actually applies to the team name. But we go into a client and we see all of the problems that they have and we stack them up and we prioritize them. And we say, in our modern methodology, don't even worry about these things. These things are probably problems. And these problems, if you don't solve them, you're not going to be successful. Your mission's going to fail.
Mm.
And so these are the things we recommend you work on. And the solution to those can be a variety of things. And we provide then the option of saying, how would you like to approach this? And sometimes the answer is there is a risk and the risk is definable and just do nothing and accept the risk. Because in a small startup, like risk posture is a knob that a company can turn if they want. And so that's the kind of service we provide. We come in, it doesn't matter if you're a startup or you're already launching something and it's already in production mode. Some clients have wanted to make those things cheaper, and other clients have wanted to know how to get things going. So we come in, we advise, and then we say, would you like to execute? And so the thought that I had about the team name is that at SpaceX, you have an EMI team, you have a software team, you have a power team, and we called ourselves the Rad Team at that time when we were a group of engineers. We did the same thing at Blue Origin. The team's name was the Rad Team. And so being here on the Rad Team, that's how we support clients in our services and our products is we act as their Rad Team and say, if we were your engineers, here's what we would do. And then leadership gets to decide the trade space of whether they want to spend the time or the money or the resources or take the risk or whatever it is to address the problems that they have from an engineering perspective.
That is fantastic. And I think that's really exciting for a lot of startups that just don't have the resources in house to do some of these things. So I think you guys are making an incredible difference for NewSpace startups for sure.
That's the plan. That's the goal. I think it's working.
Absolutely. If
Yeah.
someone wanted to learn more about the radiation team, what should they do?
That's something that we're building up as we're coming out of startup mode. Obviously, there's our website, which is going through a revamp. Our first website was because we were in stealth mode for a variety of reasons. So go to our website. Our website has a contact form. You can email info@radiationteam.com. You can email me directly. It's just my first name at radiationteam.com. I might obfuscate that if we ever get truly successful and I don't want spam. But for now, I want to be approachable. We have a whole team of people who can reach out. So LinkedIn, our website, and info@radiationteam.com.
Fantastic. Well, thank you so much for making time to be here today. Merek is very inspiring as well as informative. And yeah, we look forward to having you on the show again in the future so we can learn more about the work you are all doing.
Yeah, thanks so much for the time. Appreciate it.
Absolutely, our pleasure. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leader Show.